Okay, no problem. So now we'll start our today's session. Okay,
Yeah.
so first of all, okay, can you share your screen and then show me the problem what you face?
Okay. Where is it? Okay.
Yeah, simply share your screen.
Is it sharing?
Not yet.
Is it sharing?
Yeah, so now sharing. Yeah.
Okay. Yeah, this is my, you can see now.
Yeah.
So here, AOI, this is what I replaced
Okay.
from your code
Yes.
to get my area.
Okay.
And then let me highlight, comment of this too. So this one here is what is in your code. And when I run it, I can actually see the images here.
Okay, so it's not showing any. Okay, I think I one level added.
I don't know why it's not coming. Yeah, the images I can see,
Yeah.
but from the, is it the inspector or what? Yeah, I can see that these images are from 2023,
Yeah.
you see. But for my study, I want the images for February and January and February for 2022. Let me stick to 1 year for now because I can repeat with other years. I'm looking for the images for SPI and SPEI for January and February 2022. So I don't know where these dates are coming and all that.
Okay. Okay, so basically in this code, it's showing the date range. Okay. Okay, so in this time, we can simply change the date. Okay, if possible, you can simply share. Okay, simply get link button. Click the get link button and send me the
Yes.
code link. Yeah, click the get link button. Yeah, click on here and copy that and send me. Send me the WhatsApp.
To email,
WhatsApp you can send.
WhatsApp.
Yeah.
Uh, how? Okay, let me take it to my email first
Okay, no.
because I'm not using WhatsApp on the thing.
Uh,
All right. Okay. And then I'll open it on my phone. Yeah, I've sent it through WhatsApp.
yeah, that's I open this.
Can I unshare?
Just I also share my screen. Okay, import that. Okay, so now can you see my screen? Yeah.
Yes, I can see your screen.
Okay. Okay. So basically, in this code, now it represented the first observation date is 1981, 1st January, and in dates will be 2023, January, February, March, April, May, 31 May. Okay. Okay. So because we take all of those images, so that's why it look like that. But we can easily change the time period such as according your time period. So just I simply remove that and put here e dot date and what's your specific time first in time period
21/01/01.
2021 1st January.
Yes. Zero. Yes.
And what is the last date?
The last date is 21/01.
Okay, just a minute. Okay, so you want to observe the SPI for the 2021 1st January from 2021 February. Yeah.
From 2000 from January to February.
Okay, January to February you
2
want to,
months.
yes, and also make the time series chart.
Yes, and make the time series chart
Okay, I think
for
this.
SPI and SPEI.
Okay, SPI and SPIE.
EI.
Yeah, yeah, yeah. Okay.
SPEI.
Okay, so I think this code is mainly working for that monthly. Okay, so that's why it is a problem about that. So we need to use the another calculation about that SPI for a specific time period. Yes, so this is the SPI result.
Okay.
So first of all, this is our area, and then this is our observation time period, year of 2021, January to February. This is a color code about that, and then mainly SPI is that you can see. Okay, so first of all, you can see SPI. I will show you the formula about the SPI. SPI.
Yes.
Yes. Okay, the SPI is a z-score derivation from the mean in the units of the standard deviation. Calculate from the chart's precipitation values. Okay, for each pixel location of the computation period of each year during a given reference period. Equation is that SPI equation is that look like that. Here is the z value for the pixel I is that during time frame, and j is that year, and k j year the k. Okay, so is a precipitation values during the time frame for year. Okay, as the mean pixel value during the time frame of this given the year, and standard deviation is the pixel I during the week of the year. Okay, so
Okay.
In this time, we are using a zip data, get DLM, and then changing outcome. So that's why in this time we can get the result look like that. And after that, we can simply calculate the charts data in here according to our time period, start date and end date, and then also put here this precipitation. Okay, mainly we can get this subs data. This subs data we can use here the mean or average precipitation for our region, and also calculated the standard deviation from the precipitation. We calculated the standard deviation. Okay, and then click with our AI
Okay.
shapefile. So now same for this year. So here also put here this time period. So in this time you can also put here this time period look like the 2021. 1st January from 2021 February. It was 28. Then we can calculate the rainfall. Okay. Also calculate the average about that.
Okay.
So now we can calculate the anomaly and standard deviation for precipitation index. And now simply for the SPI, we can simply rainfall, present rainfall, subtract with the anomaly rainfall and divided the STD. So this is the equation of that SPI. And finally we show the result. We can get the result look like that.
Oh, wow. Okay.
In this type of color, we
Yes.
also change it. Suppose check the value. What is the lowest value or highest value?
Using the reducer, what reducer? The reducer function. So
I think yeah. Same for this year, but okay, USB. Yeah, so now check the value. We can get the whole year.
okay. Okay. So this one is for how is like Akira. I know that they say SPI. It can be 8 day, it can be 16 day, it can be, or this is just for 2 months. That's it.
Yeah, so only for the 2 month about that. Okay. So
Okay.
SPI 1,
All
SPI
right.
6. Okay. So we can calculate only for this January and February year of 2021.
Okay.
And finally we
Okay.
also get the result look like that. Okay. This is the SPI.
Okay. So from here, I can also download the image of rainfall, right?
Yeah. So you can easily download the image using the export image to drive function. Download this image and
Yes.
actually get the use for the ArcMap software for make your map for the SPI map.
Okay. All right. So the image for rainfall, if I may ask, will it come with the sort of the time? Because when I wanted to plot it with NC file, I changed from TIFF to NC, and it required sort of a time frame
Yeah. So
because it was long lat.
okay. So what I don't understand. Hello.
Hello, it's like, does the image come with the time, like the date?
Yeah, January and February. Yeah.
Okay, all right. And then, okay, this is for SPI. And then SPI, you also find the formula. And what?
So SPIE. Yeah.
SPEI.
Oh, okay. So this is the SPEI result for the whole global. Okay, but I need this
Oh,
result
okay.
only for this region. So just clip. So for
Okay,
clipping, I
okay.
just simply copy your region of interest.
So the data set is there in Earth Engine also.
Yeah, yeah, yeah. It also available for that. So
Oh, okay.
and for the global data set, we can easily get from here for the whole world.
All right.
Just I
Oh,
simply
wow.
copy and then clip with our shapefile and also put your own time period. Suppose 2021, 1st January from February 28. Okay.
Yeah.
Then, okay. So after that, we can simply calculate this data. Okay. Select and also calculate the average mean and also clip with our shapefile. So clip with A O I.
Okay.
And then click to the run.
Okay.
In this time, we can get this result only for this boundary. Okay, also focus the center of the shapefile. Dot center. That is the AOI. And now click to the run. Okay, so we can
Oh,
get the result.
wow.
Look at
Yeah.
that. Yes. And you can
Oh,
also export
wow.
about that from here.
Okay.
Okay, so I send you both of those data. If you want to learn the more details about the data set, okay, because in this data set
Okay.
also
The
there
chart.
it add their evapotranspiration also, and it is a combination about that. You can see the standardized precipitation and an evapotranspiration index database. Okay.
Oh, okay. I wanted to ask something. Hey, for me to export as a chart, I can just copy from our previous classes,
Yes,
the way
please.
we export the chart. All
Yeah,
right. And then about yesterday, I sent a code concerning TCI.
in my email. Yeah.
Yeah.
For the BCI TCI. Yeah, using
Yeah.
Lancet.
Because
Okay.
with the yeah, with the TVDI, I can manage others, but to clip the TCI, it was giving me problems.
Okay. So
This one is for today. Go to lines about 155, maybe from 150. There is nothing wrong with the code so far. You see, 150 is the TVDI. I managed to do it, but I'm failing to do 153, line 153, although I've commented it out.
okay. Yes, so
Line one,
TVI, it's okay, there's no problem. So, okay,
yes. The problem is 153.
153. Yeah, TCI.
Yeah, yeah,
So, take a variable
153.
TCI.
Yeah,
TCI, okay.
that one
And
was the
then,
formula. The code for it is below. Is
okay, so this
154.
type of formula is not allowed in here.
Oh, okay.
Okay, so we can write this formula. Okay, okay, TCI, okay. Okay, this formula we need to write in here like that. Suppose You already defined the all of the LST max, all LST already defined. So we need to put
Yes,
here
already defined.
LST.
I think the right formula I wrote at number 154.
Yes, yes.
That one was just a guide for me.
Okay, LST max
Yeah.
14. Yeah, subtract with LST 14. Yeah, then divided by okay. Okay, it's okay. No problem. And TCI 114. You want to TCI 114.
Yeah. It's not there. I haven't added the map layer for it.
Map dot layer. Oh,
Yeah, this is the problem I'm having.
okay, LST max 14. Okay, so you can see LST 14 max. Where is it come?
LST is up. Go up.
LST for mean.
Up. That one is for mean, yeah. Go up. That yeah, the max one is that one. Is here. 132.
Okay, but it's showing the number. So basically, it is a number. It's not a raster image. Sorry about that.
And then LST 14 is this one.
So LST 14 crops.
Yeah. And then LST 14 is 122.
Okay. Okay. So LST 14, um, LST 14 mean LST 14, LST 14, no, LST 14. It is LST 14. Okay. So in this time, we did not use at this type of code. We can simply use at the LST 14 and use at the reduce, and then put at the EE dot reducer,
Mm-hmm.
reducer dot mean. Okay, and also do for same
Yeah.
types also in here. So we put at the LST 14 and put at the reduce EE dot reducer dot max. Okay,
Okay. Yeah.
and also do for the same things. LST 14 put at the reduce, put at the EE dot reducer dot mean minimum.
Okay.
Okay, so
Minimum.
now let's check
Yeah.
again. So now it's okay.
Oh, what? Hey. Wow, you are my lifesaver. You know, I struggled with this.
Okay. So basically, first of all, it's
Yeah.
showing the result as a number. Okay, but when I make this
Mhm.
calculation using equation, I need the raster image. So in this time, when I use at the reducer, then it's showing the only raster image of the average, only maximum image of the average. Okay, and then when I put this equation, then it will be work.
Mm. Oh, all right. Okay, you'll share the code with those two.
Okay.
Yeah, it seems I'm going to be your student going forward. After this, I'm coming for air quality classes.
Okay, no problem. Okay, so I'll
Yeah.
share.
So you will send them, right?
Okay, so I send you the WhatsApp or email.
Yeah, send WhatsApp. Even email is fine. I'll I will transfer them to.
Okay, so I send you.
So you are working in a university.
Yes.
Oh, okay.
So I send
That's
you. You can
nice.
check it your email and
All right. Thank you very much.
okay. Thank you for joining.
I'll
Okay.
see you. There's no class tomorrow.
Yeah. So after okay. So now after okay. So now yeah. 2 more. Okay. So basically this class I will take for today's night. Now it for the 4:35 p.m. We take the class in the 9 p.m.
All right. Okay.
Okay. Thank you. Okay.
Thank you. Thank you very much for your time.
Okay. Thank you. Have a good day. Okay. Bye.
Bye.
Bye.